Here's some more videos of our final exam to help you. So we were just working with Luke on some of these other ones that I need to still put on there. Wow. But definitely 23 is one that we need to look at, so we'll take a look there. So number 23. Oh, so 23 is, so 23, not quite Pascal's, so keep looking to see if we can find Pascal's, but we'll show you 23. So you're multiplying it all out, kind of like Pascal's, but this is more of a pattern I noticed. So x minus 3x plus 3, if you multiply that out, that actually comes from that special thing called the difference of squares. And so that's going to be x minus, and then 3 times 3 is 9, all squared. And so that's what x minus 9, no, it's not x minus 9 all squared, is it? Wait a second. So I think it's just, oh yeah, x squared minus 9, that's it. So because x times x is x squared, negative 3 times 3 is negative 9, and then negative 3 times x is negative 3x, and then 3 times x is positive 3x, and 3x minus 3x is 0x, which just goes away. So this came from, these two parentheses there and there, came from x squared minus 9. And do you have a guess? Do you have a guess, Luca? So what does x plus 2, x minus 2 come from? X squared minus, so 2 times 2, 4. So now we already multiplied those two together, and we get to this far. And then you do have to multiply that out next. So x squared times x squared is x to the 4th power. Negative 9 times negative 9 is positive 36. And then we have negative 9 times x squared is a negative 9x squared. And then negative 4 times x squared is a negative 4x squared. And now we can combine those. So we have negative 9, negative 4, 9, 10, 11, 12. Is it 13? 9, 10, 11, 13. So negative 13x squared goes there. Bring down to our 36. And then x to the 4th power. So there's that one. There's that one. Thinking about the practice test here, I remember I do have a Pascal's on there somewheres. I wonder which problem that is. So I'm thinking, don't see one though. Interesting. I thought, pretty sure there was a Pascal's. Maybe not. Maybe there's not one. Oh, there it is. It's number 45. So number 45 on our practice test, let's try to remind you about how to do Pascal's. So we have 3x plus y to the 4th power, right? And so that's going to be row 4 is what we're going to use. So we do 1, we do 1, 1, we do 1, 2, 1, that's row 2. 1, 3, 3, 1, just adding these numbers, 6, 4, 1. So we are going to be using 1, 4, 6, 4, 1 is what we're going to be using. So we're going to go and spread that out. 1, 4, 6, 4, 1. Reminding you how to do Pascal's now. So then, do you remember? So we take that first term, which is 3x, and we write it over and over and over and over again. So we're going to take 3, and we write it in parentheses. You might have to use whoever's listening to this. Good. Using a blank sheet of paper. And because we do need there's not enough room on that practice test to do Pascal's, that's for dang sure. And so we just use row 4. And so row 4 uses the 5 numbers 1, 4, 6, 4, 1. And now we're taking the first term, 3x, and we're writing it next to each one of those numbers over and over and over again, all the way across. And then we're going to do the powers. So the powers has to do with the row. So we're going to go and use row 4, and then what do you think comes next? 4, good. 2, 1, and 0. Awesome. Then we take the next term. Let's choose another color, maybe red. And so now we're going to use y and do that all the way across. And so we're going to go and do y all the way across, those 5 terms, once again. But this time, instead of 4, 3, 2, 1, 0, we're going to do 1, 2, 3, 4. Excellent. Cool. So now we just got to go ahead and combine these things together to get our final answer. That's our pattern there of Pascal's, our pattern. So in this case, we got plus. I don't see any negatives in that problem. Good. So now we're going to do y to the 0 power. Anything to the 0 power is just 1. Just a 1. So 1 times 1 times 1. Now that 4, that power 4 has to be distributed. That's the tricky part. People make a mistake there. Don't choose 3x to the 4th power on the test. So that's a common mistake people make with Pascal's. It's actually 3 to the 4th power and then x to the 4th power is what we're doing there. And so 3 times 3 is 9, times 3 is 27, times 3 is 81. So 81x to the 4th power. Then at that point, maybe on the multiple choice part of the test, you might see your answer right away. Boom, done. But if you have to continue on more, then do that until you see your answer on the multiple choice on the test. So now this one, we have y to the 1st power. So we can bring that down. 3 to the 3rd power is 3 times 3 times 3, which is 27. So that's going to be 27. X to the 3rd power. So here's our x to the 3rd power. Now we do have to take that 27 and multiply it with the 4. So 27, 27 is 54. 27, 27, 54. Is that 108? Good, 108. I can still be a math teacher. Woo, do it in my head. Okay, so we add those together. Okay, so that one's done. Plus 3 squared is 9, and 9 times 6 is 54. Then we have x squared, y squared. Getting easier now, getting easier. 4 times 3 there is just 12, x to the 1st power, y to the 3rd power. And then, last but not least, anything to the 0 power. Do you remember what anything to the 0 power is? Just a 1. Goes away, becomes a 1, goes away. So we're just left with y to the 4th power there. So there's our Pascal's problem there to help you on the semester final review. So that's Pascal's. Awesome. So what's another one we should look at there while we're helping? Let's see. What are the factors of that? Factor by grouping. What are the factors on the zeros? That's just factoring. Not too bad, not too bad. Graphing absolute value. Already did that. So maybe we should look at number 35. That's a good one. So because that actually has some a little bit of trick to it there. So let's see here. So 35. So 35 says, please solve x plus 2, which equals the square root of 9x. And so people commonly make a little mistake here, which we don't want you to get tricked up on the test there for this. And so how do you undo the radical of the square root? Can you remember? How do we undo that square root dealio? Good, square it, power 2 both sides. So if you do it to one side, you have to do it to the other side, but you don't do it individually. No. So you actually do the whole thing, and that's where people make the mistake. You have to do the whole side, the whole left side, the whole right side. And so when you do that, you get x plus 2 times x plus 2 equals 9x, because the radical goes away. Then you have to FOIL that, right? So x times x is x squared. 2 times 2 is 4. And then 2x with another 2x is a 4x. And so a lot of times people forget that middle term, that 4x there. People forget that and make mistakes. So let's not make those mistakes. We got this. So we want to get everything on the same side now because of this 2 means that there's 2 solutions. So we want to factor it and get our 2 solutions. But first, we got to get everything on the same side. So we're going to minus 9x to both sides. So we get x squared minus negative 9 with a positive 4. Is that negative 5x? Good. Plus 4 equals 0. And then we can factor that sucker. I don't think 2 and 2 is going to work. What do you think factors of 4 that might get us to 5? Good job. So we have 1 and 4. And then I think, yep, both negative. Negative times a negative is a positive 4. And then minus 1 with a minus 4 is a negative 5. Cool. So then we set both those equal to 0. And we do get 2 solutions. X equals positive 1, the opposite sign, positive 1, and a positive 4. Now we plug them back into the beginning, and it will work. Plug 4 in there. 4 plus 2 is 6. 4 times 9 is the square root of 36 is equal to 6. Yep, so it does. Both of them do work. Cool. So that's how you do one of those crazy square root ones. One of those crazy square root ones. Let's see here. Another one to remind you about is number 37. Do you remember how to do absolute value solving? So here's number 37, where we have the absolute value of 2 plus h is equal to 10. And this is a pretty easy one, but people forget how to solve absolute value. Right? Whatever the absolute value is, it's going to make that inside of the absolute value positive. And so how we can solve for that then is if it's negative it works or if it's positive it works. So we basically have to split this into two equations. We have to do 2 plus h is equal to a positive 10, dropping the absolute value. But then you have to do another 2 plus h equals, and then what do you think? A negative 10, right? So split into two equations, drop the absolute value. And so write it just how it is without the absolute value, 2 plus h equals 10. Then do another one, 2 plus h equals negative 10. So we go ahead and change the sign of that second number, of that second right side. So change the sign to a negative now. Cool. There we go. So then we go and solve for h. So minus 2, we get h equals 8. Nailed it. And then minus 2, h could also equal a negative 12. Good. If you plug in 8 plus 2 is 10, works. Or negative 12 plus 2 is a negative 10. And then the absolute value of negative 10 is positive 10. Works. Cool. So that's another one that you definitely guys want to be aware of that we haven't seen for a while. Let's take a look going backwards a little bit. I do have a feeling about 19 that a lot of people forgot how to do number 19. So maybe we could take a look at that one. Maybe we do another video though. Let's double check how far we get there. 12 minutes? Yeah. So this is the cool. So